Alright, this is still the 2016 paper, and now I'm going to do question 3b. Right, so we're given the integration by parts formula, and now we're doing b, right? So the curve passing through the point 1, 1 has a property that at each point p, xy on the curve, the gradient of the curve is x minus 2y, that is dy dx equals to x minus 2y. I show that d e to the power of 2x and y dx equals to x e to the power of 2x. Alright. So, we're going to differentiate this. So e2xy, and we're going to use product rule. Yeah. So that'll be e2x times dy dx. Then we can differentiate e to the power 2x, which is 2e2x times y. So we want to make this to look like this. So we're gonna so we're gonna do this. We're gonna take a common factor. We're gonna do dy dx plus 2i. Can you see this? Right, 2 and y and this. Right, common factor of e to the power 2x. And now, what can we do about this? Right, we see that dy dx equals to x minus 2y, so which means dy dx plus 2y equals x, right? I rearrange it and it's going to be like this. So that is just x e to the power of 2x, and that's done, right? And then hence or otherwise find the equation of the curve. Okay, so they've given us the curve, that's e to the power of 2x, then y. But we cannot find anything from that because, well, it's just an expression. So, and it has a y in there, so we can't really do anything with it. So, what we can do is, we said that the derivative of e to the power of 2xy is x e to the power of 2x, which means the integral of x e to the power of 2x equals to e to the power of 2xy. So I'm going to integrate this. Right. So how do you integrate that? We need our integration by parts formula, right? So we got that f and g dash, then f g, then f dash g. So what I'm gonna do is I'm gonna call f my easiest. Well, that's the easiest to differentiate, right? The function that's easiest to differentiate. So I'm gonna call f x. So f dash is just 1, right? Because we're just gonna use f and f dash, right? F is x and f dash is 1. Right, that's very easy because if you look here, we're going to use f dash times g, and which means I only have g here, right? Much easier. So then we're going to call g dash e to the power of 2x, which means g will be half e to the power of 2x, right? Because if you differentiate that, then the 2 is going to come off, then, yeah, e to the power of 2x. Right, so now, integration by parts equals to f times g, which is x times half, then what, minus the integral of f dash times g. F dash is 1, right, it's 1. So g, what is g? It's half 2x dx. Right. Do you see that? If I call f e to the power of x, e to the power of 2x, which means for this part, we're going to use integration by parts formula again. And we don't want to do that, right? So f will be the easiest to differentiate. Right, so that's going to be a half x e to the power of 2x. And this is, we're going to integrate that. So, well, very easy. A quarter e to the power of 2x, because if you can differentiate that, the 2 comes off. So that's going to be a half, right? Don't really need to talk about that. So, but yeah, that's it. So this thing equal to e to the power of 2x y. Correct? So remember, every integration we have a c here. Okay, so in order to find that c, we're going to use the coordinates of the original curve or the function to substitute, and then we can get the c here. So we said that this passes through a point 1, 1. So I'm just going to substitute that. Everything y and x by 1, so that's just e to the power of 2x equals to, no sorry, e to the power of 2 actually. So a half, then minus plus c. So which means, sorry, so c equals to 3/4 e to the power of 2. And so what we can do is take this, right? We've got a y here and these kind of stuff, so much easier. Remember, this equals to this, okay? Then we can take a common factor out, which is e to the power of 2x, and that's going to be, right, we can divide everything by e to the power of 2x. It's gone. And c is this, then this is going to be divided by e to the power of 2x. So y equals to right, we're just going to take this up and make this e to the power of minus 2x, so they're just going to be this straight away. Right, thank you.